Thank you very much. Good afternoon, everybody. I've been in 22 standing in Berlin at the PDF days here telling the audience about plans and what we were doing in the LaTeX project in terms of trying to get automatically accessible PDF directly from LaTeX. And back then I was largely talking about the roadmap that we had and the first little bits and pieces that we were already being able to do. Now it's 25. We are back at PDF days, and so today part of the talk is going to tell you what the hummingbird in the middle was doing between those 2 dates. In particular, what I'm also going to do is to talk about, in general and in specific examples, about the difficulties that exist in STEM documents, so in documents with fairly complex content, in particular with mathematics, if it comes down to having those being accessible for people who actually need accessibility and get to the content in a different way than having the PDF seen on the screen or on paper. So I will briefly talk about LaTeX role in the STEM world. Then I will show a little bit about these accessibility challenges. And when we take a look at UA1 as one means to make documents accessible, we will then look at UA2. And at the very end, I will talk about an end-to-end workflow to make accessible, make STEM documents accessible automatically using LaTeX as a starting point. Okay. So this is something I said in 22 already, so just a very brief recap. LaTeX, if it comes to STEM documents, especially with mathematics, is sort of one of the core producers of STEM documents. In computer science and physics and mathematics, we have Overleaf since a couple of years. By now they have more than 20 million users who do sort of collaboration on the internet using LaTeX as the underlying basis. We have many journals that produce their output using LaTeX as input. There's this big archive for preprints, archive.org. That archive is to 95% LaTeX based. In other words, most of those documents in that field are served by using LaTeX as the starting point. Now, here is a little bit of very simple mathematics. They are not meant to be extremely clever. They are meant to serve as an example. And what I want to show to you is, or rather have you hear it, is to give you an idea what happens if a document that is just a print PDF is given to a speech reader, and what the receiving party is then able to hear. So we go high-tech now. I use my phone to do this, and I hope it works.
Formulas n, x, n plus 1, n, I equals 1, 2, I equals 1, a plus b, a minus b, equals a 2 minus a plus b a minus b2, 2, equals a, 3, 2 minus b2, 1211 13, equals 3401 1.
Okay, I hope you could hear it, and I fear you couldn't understand it, given the mathematics, what was actually told by the speech reader. Basically, at the moment, most STEM documents are still untagged. So this is the input to the speech reader. If you get mathematics, the mathematics are totally incomprehensible. I think you will agree that this was not what was on the screen, right? So in that sense, the keynote speaker in the morning gave these examples on the web of people saying PDF are evil, they should be replaced. In the accessibility community, that's the general sentiment. If you are having STEM document content, you cannot understand it if you have an untagged PDF. And so it is understandable that given that we have so many untagged material, which is totally incomprehensible, that this is a real problem for people who actually have the need for it. So the question is, does it have to be? So we can do better. We can tag the stuff. And one standard here is UA1. If you have UA1, then UA1 mandates the use of PDF 1.7. That's where it is based on. And the problem with 1.7 PDF is it doesn't understand the content of a formula. The formula is just a graphic. So basically, what then UA1 is saying, you have to use alternative text to make the graphic, the formula, accessible. Now, is that possible? If you look at a typical math document, a mathematical article, then you have between 50 to 100 little formulas on each page. Here's an example. I mean, this is taken from a random recent article on archive.org, bits of this, and these parts are all formulas. So if an author had to explain for each of the highlighted parts what the meaning of this formula is, you have an impossible task, right? So basically, it's unrealistic that the author is actually doing that. There's no way that an author goes in and explains for every formula what the meaning of that formula is. First, that's the first problem. The second is, even if he or she is doing it, a verbal description is very likely to be inaccurate and difficult to comprehend if you are on the receiving side. And finally, if you do this after the fact, any change of your document means you have to redo all this textual annotations, right? So as a bottom line, if you use the UA1 standard to make your documents accessible, that's fine for simple documents, but if it comes down to STEM documents with complex content, with formulas, it basically stays inaccessible because either it's not done or it's not done properly. If somebody just has the need to have a check mark and it makes every formula alt text, this is a formula. The content is probably getting its check mark, but it will not help anybody who needs to understand the document. Okay, but you can do a little bit better. If we are with LaTeX, one thing we can do, we can actually automatically put the LaTeX source into the alternative text. No author involvement in that case. So the positive side is this can be done automatically. It is not requiring a post-processing step. It's also good. And in fact, many people in the STEM world that are dealing with mathematics, physics, and so on understand LaTeX as a source input, so they can actually comprehend if they get the source being read to them. But there are downsides. First of all, the source is still very verbose. So if somebody gets it read, that might work. If somebody wants to read it on a Braille device, instead of getting a couple of Braille characters to describe the formula, they get long English words or German words or something describing the formula from the source perspective. So it is many lines of Braille display, and the Braille display has a single line of input, compared to a very concise way of representing mathematics in Braille. So that's second level quality. And finally, it requires the author to be very consistent and standard in his LaTeX source. If the author makes its own abbreviations in LaTeX, which many people do, the source will not be understandable because you are getting the source out of context without having an idea what the abbreviation the author put in actually means. So it requires the author to be producing source in a way that it can actually be understood out of context. So this is sort of a downside of the whole thing. It is better than nothing, but it is second-class quality, basically. But we also have UA2. UA2 is based on PDF2. It has one big advantage for the STEM world. MathML as a name as a structure is explicitly supported. So there are two ways to describe formulas using MathML in PDF2. One is the MathML can be embedded for the whole formula in form of an associated file. The associated file is then attached to the formula. The alternative is to use PDF structure elements that are named after MathML, and then you have basically the formula as part of the structure tree. So the big advantage in that case is that you can navigate the structure tree, and that means you can navigate the formula if you have an IT device that helps you with doing this kind of thing. So, are we fine in that case? Well, a bit yes and no. First of all, we have a problem that PDF2 introduces MathML and the use of MathML, but a lot of things have been left undefined in the standard. It basically says you're allowed to use MathML, but it doesn't really say how that should happen. So there's a problem that we have no precise mapping between the PDF MathML structure elements and the actual MathML out there that would then be used by the speech reader or whatever. So there's a missing link. There are also other things like there's no explanation given how things like nested mathematics should be handled. So if you have mathematics which has some text inside, which in that text has another piece of mathematics, how these kind of things should all be sort of worked out and be presented as part of the structure tree. So there were open questions that needed to be resolved. So before 25, basically, we had no producers for this, and we had no implementations whatsoever. So basically, nobody was producing PDF with MathML inside. There were no readers that were PDF readers that were actually expecting MathML inside the PDF. Therefore, they were not giving the MathML to the AT tools. So even if there was MathML, if you would produce a PDF with MathML inside, well, basically nothing would happen if it comes down to the accessibility side. And then finally, also the AT tools need to understand that they get MathML and actually do something with it. So all these things were missing, basically. And then there's another problem, which was discussed, I think, during the conference already in one or the other place. The accessibility checkers out there. Basically, everybody was testing for UA1. And there are differences between UA1 and UA2. One of the big ones is UA2 supports MathML. And so most of the checkers got very confused if you were giving them a UA2 document, because they were trying to validate it against UA1 as the target output. And then things failed. So valid documents were actually, or still are actually, in some cases, being flagged as invalid documents according to the existing checkers. So that's a big problem here. So is there a change this year? And yes, we have a couple of changes. The biggest one is we now have this workflow that is actually end-to-end working. Starting from LaTeX, well, actually it can also be from other places. Word is starting to follow as well. Starting from LaTeX to produce documents using a PDF format which is suitable for STEM documents. In other words, PDF 2.0, to support the mathematical formula, etc., the chemical formula inside the document in a structured way. Then we need a reader software which has the ability to process that MathML, and fortunately, we now have 2 readers at least that do this. Foxit is at the current point in time able to accept MathML if it comes in associated files and in structured elements. Adobe Reader Acrobat is able currently to do it if it comes as structure elements. If it comes as associated files, which is the easier way to produce, so for example, Word or Office Libre would produce it as more easily as associated files. It is currently not yet there, but hopefully this will happen. Well, there are rumors it will, and I strongly hope that this is coming true. We don't know about others, but hopefully that is changing now that more and more documents with PDF2 as the basis and UA2 as the standard are actually coming out there. And we have now assistive technology that can handle MathML in the PDF context. The ATs were able to handle MathML if it came as part of HTML for a long time, but when it came through the path of PDF, they were sort of closing their ears on it, so to speak. The first one who's actually doing it properly is NVDA. It is on the roadmap for JAWS, but it's not yet there. And the other thing that is important, the AT tools need to use a library of some sort that really can interpret the MathML correctly and produce proper speech from it, produce proper Braille from it. And the open source library MathCat is doing that. And the two here work in conjunction. So this is now offering for the first time a workflow going from the source with no extra work from the author down to the assistive technology, either as Braille or as speech or whatever you want to have or can have afterwards. So let me try to do the same document once more, but this time with a tagged version in PDF 2 and UA2. Let's see if I get this right.
Formulas. One line.
No.
With label 1. The sum from I is equal to 1 to n of I is equal to...
Stop. You can't hear that, can you? Let's use this one. Oops. Yeah, that's better. Let's try it once more. And I press these for you because I don't have 3 hands. Let me see. Okay, this and this.
Formulas. One line. With label 1. The sum from I is equal to 1 to n of I is equal to...
Doesn't come through, does it?
Greater. Open paren n plus 1 close paren times n. And denominator 2. 2 lines. Line 1 with label 2. Open paren a plus b close paren times open paren a minus b close paren is equal to a squared minus av plus ba minus b squared. Line 2 with label 3 is equal to a squared minus b squared. The 2 by 2 matrix. Row 1. 1, 2. Row 2. 3, 4. Times the 2 by 2 matrix. Row 1. 1, 1. Row 2. 0, 1. Is equal to the 2 by 2 matrix. Row 1. 1, 3. Row 2. 3, 7.
I hope it was... I couldn't hear it from here very well, but I hope you got the gist. Basically, a lot of this is coming from MathCAD, so the structure that was in the PDF was interpreted for English reading of mathematical formulas. So things like paren times denominator, the sum of is equal to, and so on and so forth. They are not part of the PDF. In PDF, we have the MathML, and the MathML is interpreted. So if you want to hear the same document in a different language because you're preferring to listen to the mathematics in German, it would be able to read the same thing in a German formula. If you are very good in mathematics, you don't need a lot of hints. You can alternate the amount of information that is actually given to you. So this was clear speech. I think then there is simple speech and other mechanisms that you can tailor as a user of NVDA and MathCAD. So you get a lot of flexibility in terms of the output. And this then enables you as a user, I would say for the first time, to actually have a PDF where the mathematics is understandable for you if you get it as Braille or you get it as speech, rather than looking at it with your eyes on paper. So, is everything fine now? There's still a lot of work. As I mentioned earlier, we still in very early days in terms of the support for PDF2. We have now more than 0 tools that can do it, but it's not as far as it should be. I hope this will change through the fact that next time when Boris is making his statistics, we are not having 0 point something percentage of PDF2 in the field, but a large number of PDF2 documents, and therefore readers and other tools will start to actually sort of working on this. So that's hopefully good soon. The same is true for the AT support. Right now, it's only working on Windows. On the Mac, you have basically VoiceOver, but VoiceOver is not using structure as far as we can see so far. So maybe that is also a big area where we hope things will get better. And it's only available at the current point in time in NVDA. And what I said earlier, one problem, which is more like a perception problem, is that we currently have checkers that do not understand PDF2. Therefore, they make actually mistakes and telling you that your document has a number of errors, where in fact it has not, because it is based on the PDF UA2 standard and not on the PDF UA1 standard. One example, you have a table and you have some rules in the table. In PDF UA2, you would artifact the tables. So you have artifact structures in the middle of your table structures, and UA1 would go crazy on that, and the checkers go crazy on it too. So that's one example. The other one is mathematics are simply misunderstood, and so the checkers are telling you, you need to have an alternative text. No, you don't, because the structure is there, but it is not yet there. Which of course is a problem for universities and other places where the checkers are in place. People have to use the checkers to check that their documents are compliant, and the checker is telling them they are not. And the only way to make them compliant is to degrade the quality of the PDF instead of actually producing PDFs that are useful to get your check mark. So I hope this is going to change as well pretty soon. So, which brings me to the end of the talk, so sorry for being too fast. It's kind of the first blossom in the desert, and I think it's great to actually be able to automatically produce these kind of things now. The next step is now to broaden the support for actually PDF UA2, so that it is getting to a world where the PDF of complex documents are actually useful and understandable, and the sentiment of PDFs are evil is no longer something that is voiced because it's no longer true. Okay, thank you very much.
Thank you, Frank. Any questions?
Well, thank you very much, Frank. And to which extent this LaTeX part is available to just a regular researcher who is not really an expert in LaTeX?
This way of generating accessible UA2 documents is available to any LaTeX user by now. It's part of the standard distribution, if I understand the question correctly. So,
but do they need to go to Lua LaTeX or development version of Lua LaTeX? Or is it just here with the standard default settings anyway?
It works with the standard default settings minus a single line of extra input at the very top. Those people who went through the poster sessions, in the example of the poster sessions, we had this one line, which is basically saying, use tagging. and it has to come at the very first part, and then the rest of the document is just the normal LaTeX document as you have been before. Sorry? Lua LaTeX is the better output, but basically, yes, you should use Lua LaTeX because that gives you much better quality in terms of the mathematics, because Lua LaTeX is the only engine that can automatically generate the MathML. If you use PDF-Tag, which is one of the other engines, you cannot generate the MathML automatically. You have to get the MathML some other way. But if the MathML is produced from the source of LaTeX, but by a different process, then you could also use PDF-Tag. But the best approach for the future, for people who want to make accessible PDF, is definitely Lua LaTeX as the engine, Lua Tech as the engine, and then this one line on top, and then you get it automatically. What you don't get automatically, of course, is alternative text for graphics. You still, as an author, are required to do this for your graphics, but not for the mathematics. The mathematics comes for free. For the graphics, you have to explain that. That's the one step that the author has to do if he wants to get accessible documents and he or she has graphics inside. The other thing, which is still a restriction, is we do not support all of the LaTeX universe, which exists out of 5,000 to 6,000 packages, add-on extensions. Out of that, we have something like 1,000 which are currently supported, which cover the majority. It essentially means if you want to get a document in an accessible document, you are restricted to a subset of the whole of the LaTeX extensions. And the number of extensions that are becoming accessible or supported is growing, but we are not at the complete set because that's a huge universe. That's a restriction.
Other questions?
So thanks, Frank. Yeah, you mentioned that people understand LaTeX, and originally in 1.7 you would probably expose the LaTeX interpretation of math through alt. Now you are giving away a lot more. Do you feel a pushback from people understanding LaTeX? They want a LaTeX back in some alternative way, or?
It's maybe too early to say that. I know that when I was talking at the DIMES conference, which is a sort of mathematical conference on accessibility in Tokyo in 2024, a lot of the people there were saying, but we here in Japan are quite used to reading LaTeX. It would be very nice if you can just give us the LaTeX. At that time, we were not able to use the MathML yet. That was 24, so it was in the pipeline, but I couldn't demonstrate the advantages or anything. So there were certainly people in the accessibility community who thought LaTeX as a source is good enough for us. In fact, what we have now is the best of all worlds, because we can, the moment Foxit and Acrobat use the right kind of things, like by default having structured text being sort of the go-to solution if it's there, and alternative text be as something that at the discretion of the user being also used, we could produce MathML and at the same time attach the LaTeX source either as an as an associated file or as an alt text. So for tools that are not understanding MathML or not doing that, they could still use the alt text. So those kind of things are possible, and it has to be seen by we have to understand what the community really needs, and it might be different for different people.
Any other questions? Maybe just the final question. Do you think if we met here in 3 years, the cactus will bloom fully?
You never know, but our goal, yes. Our goal is doing what right now we can do new documents. And actually people can produce accessible documents directly without a lot of hassle because it's in the distribution, everything. Fine. What we can't do yet is all these huge corpus of existing documents, like in archive.org, all these research papers that are written 10 years ago, or 20 years ago, whatever, 5 years ago, out there. We want to have those accessible too. And the big advantage is, in most cases, they have the LaTeX source still available. So the idea is that we go in, recompile those, and get accessible documents as well. We wouldn't have alternative text for graphics, but you could get a lot already automatically. Now, that requires this LaTeX universe of packages be more or less very much supported throughout, because what you find out there is a huge mess of different kind of things. So at the moment, I wouldn't expect that we get more than maybe 5% of these old documents, but I want to get to something like 70%, getting those really, really supported automatically. And that's the goal, and I hope in 3 years I could report, yes, it's a common standard. Everything that is produced with LaTeX is automatically UA2. B, we have managed to get archive.org basically done, and other places as well following suit. So that's the goal and that's the vision. We will see in 3 years.
Any final question for Frank? If not, Frank, thanks again.